Section 9.1, we're looking at sequences and series. So in 9.1.1, we're going to start with sequences. So what is a sequence? So I think it's easiest to start with an example of a simple sequence. So it's a bit of inductive reasoning or looking for patterns. So for example, I might list some numbers, 3, 6, 9, 12, and ask you, okay, what comes next? And you might say, well, let's see, what's the pattern here? The sequence seems to be following this pattern of adding 3 each time, or 3 times the number. So my next number should be 15. And you'd be right. So that's a sequence. And then this would just keep going, or not, depending how I want to define it. Let's try a little harder one. Let's say, for example, I start with my first term is x plus 2. And then my next term is 2x plus 4. My next term, 3x plus 6. And my next one, 4x plus 8. What do you think my next term would be? So go ahead and pause the video and see if you can find the pattern and identify what that next term is. If you said 5x plus 10, then you did find my pattern. So now that we've kind of built what a sequence is and got an idea of that, let's look at the official definition. So a definition of sequence says, a sequence is a function whose domain is a set of positive integers. The function values or terms of the sequence are written as a1, a2, a3, a4, blah, 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 up to an. So how does this work as a function? So for example, my first term is the x plus 2, and I actually call that a1. That second term, that's a2. The third term, that's a3, and so on. So as a function, and when you think about like the domain and range, mapping to the domain, mapping to the range, thinking back to, I don't remember what unit, but our earlier function units, the domain here, I have listed 1, 2, 3, 4, 5. And so where does it say that? Let me see. The domain is a set of positive integers. So 1, 2, 3, 4, 5, and it could go on or not, depending how I define the sequence. And the range is this is really saying like the first. So A1 was the x plus 2. And 2 maps to 2x plus 4. So my pattern is that I take the domain, whatever the x value is, in front of my x and add twice that. So that was my pattern. So when my input was 4, my output is 4x times 2 times 4, which is 8. And then you hopefully found that pattern as well when you found 5x plus 10. All right, so here you can see that a sequence is really a function, if you think of a function this way, with that domain being some set of positive integers. All right, so let's look at some exercises now that we understand what a sequence is. So our first set of exercises is 1 through 12. And we need to write the first 4 terms of a sequence, assuming it starts at 1. Excuse me. Okay, so let's look at number 2. If this defines my function, then I can think of this function as, remember all of these functions are going to start at 1. So I can go 1, I need to do the first 4 terms. So I'm going to do my inputs, my ends are going to be 1, 2, 3, and 4. And my output, so that's the a sub n, that's the n squared. So when n equals 1, then n squared is 1. When n equals 2, the n squared is 4. When n equals 3, n squared is 9, and n is 4, n squared is 16. So the first four numbers of my sequence here are, not really an equal sign, are 1, 4, 9, and 16. All right, let's do that again. So again, we have four terms starting with n equal to 1. 1, 2, 3, 4. So when n equals 1, this thing, which is a sub n, is 1 plus 1 in the numerator over 1. So that's 2 over 1, or just 2. And when I plug in a 2 for n, I get 3 over 2. And when I plug in a 3 for n, I get 4 over 3. And then when I plug in 4, I get 5 over 4. So there's my sequence, or the first four terms of my sequence. All right, one more example of this. And this one is kind of special because it's got this -1 in front. So that -1 is a handy way of creating a series that alternates sign. So this part is really just telling me what's the sign going to be. So when this exponent is even, that is just multiplying by 1, +1, so it doesn't change the value. And when it's odd, you're multiplying by -1. So every other item will be negative. So I'm going to actually, for this one, I'm going to do 4 blanks for my sequence. So when n equals 1 in this blank, when n equals 2 here, when n equals 3 over here, when n equals 4 here. I'm going to fill in those blanks. I'll turn those blanks a different color so it doesn't look like it's part of our number. Whoops, too much changing. Sorry. There we go. Okay, so when n equals 1, then I have, up here I have n plus 1, which is 2, which means that's going to be positive. When n equals 2, then I'm going to have a 3 in the power here, which means that's odd. So a -1 to an odd number is still negative. So I'm going to have a negative there. And then it's going to alternate from there. When I plug in a 3 for n, I get an even, so it's positive. When I plug in a 4, it's odd, so it's negative. And it just continues alternating. So this idea of taking -1 to a power is a way to represent an alternating sequence. So you can use either n or n plus 1, depending on if you wanted to start with a positive or start with a negative. So think about your first number, if it's going to be positive or negative, to decide if you're going to have n plus 1 or n. So in this one, you can see that our first number, it starts with a positive and alternates from there. Okay, and then what's left after I get the sign is n squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So there's my sequence, or the first four terms of this sequence. Okay, so that's 1 through 12, and you're doing every other odd from that section. So let's go on to the next little section, which is 13 through 20.